And we are back for another pre-calc video on conic sections, chapter 9, section 2. And you are my pre-calc babies, whether you like it or not. Ready? So let's get started. So the conic section that we are interested in for this section is what we call the hyperbola. And what you're kind of noticing, I've went ahead and put the graph of a hyperbola here in front of you, and you can see that for a hyperbola has two distinct or disjoint parts that we call branches. And we're going to start off with the easiest case, where the center is nestled at the origin. But let me go ahead and read the definition of a hyperbola, and then I'll tell you a little bit more about this lesson, and then we'll jump in. Ready? So the definition of a hyperbola goes something like this. It says, it is the set of points in a plane, the difference of whose distances from two fixed points is constant. Now, the difference, right? The difference of whose distances from two fixed points is constant. So let's see if we can make sense of that. So I'm gonna let's just say this point right here, this is some xy point, we'll call it P, that is on the hyperbola. Now, just like with the ellipse, there's 2 points, that what we call the focal points, that we use to define the hyperbola, right? And that's what you're noticing here. There's a distance. There's a distance from each focal point to that point P. Now, in this definition, it says the difference, meaning subtraction, right? So if you take distance d sub 2 minus d sub 1, that's the difference between the distances, is always constant, right? And it is always the same. And now, let's notice a few different things, because this is going to be a quicker video, because the techniques that we're going to use for the hyperbola are very similar to the ellipse. So we have all of our theory. Let's just note some of the noticeable differences. That for the hyperbola, there are only two vertices, right? As opposed to the vertices and co-vertices of an ellipse. So this is, I don't like this color. Let me see if I can grab another color that shows up better. So this is our point A, and this is our point negative A. And what you're noticing is starting, if you think about it, if you start at the origin, if you travel a distance of A to the right and a distance of A to the left, we have this axis, right? Now, the axis that I'm basically going to talk about what we mean by the transverse axis. So the transverse axis runs through the focal points and through the vertices. Through focal points, the center, and the vertices. And the length, well, let's say not the length of the transverse axis, I should say. Let me erase that statement for just a second. The length of the difference of the distances from the focal points. So, in other words, once I take the distance from focal point to our point on the hyperbola. And notice that we're taking the absolute value of that difference. So minus the distance from the second focal point to the point on the hyperbola. This remains constant throughout the movement of the particle, right? So if you can imagine this point P moving up and down this branch of this hyperbola, and it is always equal to 2a, right? All right. So, as I said, for the most part, the techniques that we used in the previous the section on the ellipse almost perfectly mirror the techniques that we're going to use on the hyperbola. So we're not going to stay here very long, but so let me go ahead and show you the two types of hyperbolas that we're interested in, right? And again, we'll start with the idea that it's centered at the origin. So notice that the first example, now we can call this a horizontal hyperbola if you'd like to think of it like that. But what we really mean is that it has a horizontal transverse axis is really what we're trying to say. And notice the branches. Notice how the branches are, the directions that the branches are moving. Now, what we want to do is compare that to a vertical hyperbola. And now you notice that the branches, the direction of the branches, now they're moving. And of course, by vertical, we mean that it has a vertical transverse axis. Okay, so the transverse axis is running vertically here. The transverse axis is running horizontally here. Now, what I'd like you to do is just take a second and look at these two equations and tell me what is, because they almost look identical to the ellipse, the equation of the ellipse in standard form, but what is the only difference, the real difference? Right, so instead of adding, we're now subtracting, right? So y squared over a squared minus x squared over b squared, x squared over a squared minus y squared over b squared. And let me go ahead and make a statement about how do we know if it's vertical or horizontal, okay? So for a horizontal hyperbola, now it is true that we mean the transverse axis is running horizontally. But here, let's just have a takeaway. Ready? How about this? The x squared is positive. Right? That's the main takeaway. The x squared is the positive term. So notice that for the horizontal, you're subtracting your y squared. And it is the opposite for vertical, right? So for vertical hyperbolas, I'll go ahead and write that up here. We would have for vertical, the y squared is positive. Okay. So, but the game is really the same. I mean, either I give you an equation of the hyperbola and ask you to find some information about it, or I give you some points, focal points, vertices, and ask you to find me the equation, right? The game is still the same. So what we must have is the relationship between the vertices and the focal points. Now, I think I'll say something really quickly. So the distance A, right, is always on the transverse axis. So this is the distance A, you may ask, well, okay, Professor, I understand where the focal points are and how and where they represent, and I understand how A represents the transverse axis, but what is the B in this problem? And the way you would think about it is there is, I won't go into great detail, but you can imagine there is another axis. Okay, not the transverse axis, but it's another axis that runs perpendicular to the transverse axis, which I'm drawing a blank. I believe it's the conjugate axis. But you can imagine that there's some point B and negative B on that axis that takes the role of the B squared in our equation that relates vertices to focal points. Okay, so again, you can kind of imagine these asymptotes that are running through the origin that look like this. And I hope that that picture is not too cluttered. All I was trying to do is say, look, this B does actually mean something, and I was trying to give you a geometric interpretation of what that B represents in our in our graph. But the good news is the game is the same. So first question, I give you an equation, and what do I ask you to find? I ask you to find the vertices, and I ask you to find the focal points. All right, well, so let's go ahead and start. So there should be 2 vertices, and there should be 2 focal points. So the job is to provide 4 total points to answer this question. All right, so your first things first, your job is to figure out, is this equation what we're going to call a vertical or a horizontal hyperbola? Well, if you have to refer back to what I had on the previous page, if the x squared is the positive, then it's horizontal. If the y squared is the positive term, then it's a vertical. So let's take a look again. So in this case, we have the x squared is positive. Therefore, this is horizontal. And what I'm going to do right now is write the generic form of the horizontal ellipse. So this would be x squared over a squared minus y squared over b squared is equal to 1. Okay, so far so good. Let's now go ahead and identify that in this case, a squared is equal to 16. That means that A is going to be equal to plus or minus 4. Okay? And in this case, let's see what else we have. So in this case, b squared is equal to 9. That means that b is equal to plus or minus 3. Ready? I'm just going to, this doesn't require that I do this for this problem, but I'm just going to go ahead and plot this out. So this is a horizontal hyperbola, meaning the transverse axis is running horizontally. I'm going to go 4 to the right, starting at the center. So I have 4 to the right, it's here. This is A. And 4 to the left, here, this is negative A. All right, so I know that my hyperbola is going to look something like this. Now, what I need to do is figure out the focal points, right? So notice that the focal points are always going to be behind the branch, or you could say it as the branch opens towards the focal points. And so let me start with answering the question of the vertices, right? So there's only two vertices. So right here are your vertices, right here and here. So at A and negative A. So that's easy enough. All I have to do is go ahead and write those as points. So negative 4, 0, and 4, 0. There's my vertices. And there's only two more points that I need for this problem. And in that case, it's going to be the focal points. I need to come back and grab this relationship because this is different from the ellipse. I need to grab the relationship, so of how the focal points relate to the vertices. And let's go ahead and plug in the information that we know. So, ready? Let's go ahead. So, do I know c squared in this case? I do not. So c squared is equal to, do I know a squared? I do, it's 16. Do I know b squared? I do, it's 9. So therefore c squared is equal to 25. C is equal to plus or minus 5. All right, so this is C, this is negative C. These are our focal points. All I got to do now is turn them into points, right? All right, so since the focal points are going to be on the same axis as the vertices, the transverse axis, I'm going to go ahead and write negative 5, 0. 5, 0, and we're all done. All right, one more, last one for this section. So now you're given some information about the hyperbola, right? You're given the focal points, you're given the vertices, and it's our job to see if we can figure out the equation. All right, so the first thing that you should be asking yourself is, wait a minute, is this going to be a horizontal or a vertical? Right? So we got to structurally, we got to make sure we have the right form for the equation. All right, so look at the focal points, right? Because what answers this question, is it horizontal or vertical, all stems from the location of these focal points, right? So to the location of the vertices. So notice how, and if in the beginning, if you have to, you can just, things make sense if you look at the geometry, right? So if you have to, you can go ahead and plot these points, right? 0, 3, let's just say that's here, 0, negative 3, then 0, negative 2, 0, positive 2. So that means the hyperbola running through the vertices looks like this. Let me draw that a little bit better. Okay, so I automatically, just from the location of the focal points, location of just using those focal points, I can figure out that this is definitely a vertical ellipse. And if you recall, when it comes to a vertical ellipse, the x is the squared is the negative term, right? Remember me saying that. So for a vertical, we're going to have y squared over a squared minus x squared over b squared is equal to 1. Okay, so the x is negative, x squared is negative in a vertical hyperbola. Okay, so now all that's required is I know what a squared is and I know what b squared is, and we can finish this up. So, all right, let's start with the easiest one. So a squared So remember, if you start from the center and you travel a distance of a, right? That's how you get to the vertice. So in this case, a is equal to 2. Therefore, a squared is equal to 4. All right, so beautiful. I already know what to put here. Now, the only thing that I'm going to need to figure out b squared is the relationship between these points. All right, ready? Let's plug in. So first off, what other information do I know? Do I know the distance c? Right, that would be the distance from the center to the focal point. Right, that's c. Well, I do know that, right? It's right here. The distance of c is 3. That would mean that c squared is 9. All right, so now let's just put everything in the right spot. So c squared is 9, and that is equal to a squared, which is 4, plus b squared, and you got it. We're going to solve for b squared. So subtract 4 from both sides. I have b squared is equal to 5, and that means that b, well, actually, you know that I can stop right now, right? I almost made the mistake. Think about it, what I just said. We want b squared. And as of right now, we know what b squared is. B squared is equal to 5. All right, so let's write the equation, right? We were asked to write the equation of this hyperbola, and we're going to do it. So y squared over what? Over 4 minus x squared over 5 is equal to 1. That's the equation of the hyperbola. So as I said, it's the techniques are very similar to the ellipse, so that's why we're not going to spend a lot of time here. When you get into your homework, you'll get some more practice with some various questions. If we had the time, I would show you a pretty interesting application, or some pretty cool applications of the hyperbola. But given the setup and the time constraints, we're just going to have to keep moving. I will see you again next time.